Hello everyone, this is Nirmal. Today we are going to start a new chapter, playing with numbers. This is the ninth chapter of your syllabus. Okay, chapter 9 it is, playing with numbers. Let's continue. Let's start the chapter. The first topic is the simplification of brackets. You must have seen the questions containing brackets. So how to simplify the questions which have the brackets. So brackets are the groups. Brackets are grouping symbols which are used to indicate a part of the expression which should be evaluated first. It means brackets are, what are the brackets? Actually it contains the group of the symbols. Means brackets are the grouping of the symbols which are used to indicate that the whatever expression is there inside the bracket, that should be evaluated first, means that should be solved first in the question. So what are the points? That if an expression contains one set of brackets, evaluate that part first. Okay, means brackets should be evaluated first, that should be solved first. If an expression contains two or more sets of brackets, then one inside the other, then evaluate the innermost set first. Suppose that this type will be there. This is the bigger bracket, we can say. Okay, and inside that curly bracket and inside that small bracket is there. Then if many brackets are there, brackets inside bracket, then what will we do? That will we will solve the expression which is inside the innermost set of the bracket. Okay, it means like this. If this type of question will be there, then at first we'll solve the small bracket, then curly bracket, then bigger bracket. We'll understand through the examples. Suppose that this is the example in the question number A. Okay, in this what you can see that expression is there inside the bracket 6 plus 8. So at first we will solve that. Means if the question contains bracket, then we will solve that first. So here as you can see that 24 minus 6 plus 8 whole minus 3, and then 6 plus 8 we will solve at first because it is inside the bracket. So here 24 minus 8 plus 6 14 minus 3, it means again you will solve, then 24 minus 14, then 10, and then 10 minus 3 is equal to 7. So we have got that how to solve the questions containing bracket. Here also the same example is there, that bracket is there, then at first we will solve that. So 19 divided by 15 has been solved at first, it means 6, and then divided by 3, then 2. So like this we will solve the questions containing the brackets. Suppose that more than two brackets will be there, brackets inside brackets, like this type of question or this type of question, then how to do? So let's see the question, this question, that inside the bracket, inside the bigger bracket, a small bracket is there. So what will we do? We will solve the expression which is inside the what, innermost bracket. Okay, so that will be solved first. So here we can see that in the innermost bracket 9 divided by 3 is there. So at first we will divide that, we will solve that. So 12 plus this will be divided, then we will get, if it will be solved, okay, then we will get 3, and then we will solve the outermost bracket here. So 12 plus 3 15, then 15 minus 16 is equal to minus 1. So we have understood that what we'll do, we will evaluate the inner bracket first. Okay, innermost bracket will be solved first, and gradually we will move towards the outermost bracket. So here also we will do the same thing, bracket inside bracket is there. So innermost bracket will be solved first, it means this will be solved first, 4 plus 5. So 21 minus 4 plus 5, then 9 plus 2, and then bracket, and it is multiplied by 2, then we will solve this bracket. So we have understood that how to solve the brackets. If only one bracket is there, then that will be solved at first. If more than one bracket are there, it means in brackets inside bracket, then innermost bracket will be solved at first. So we have understood this. So there are four kinds of brackets actually. So like bar or vinculum, this one bar, it is known as bar. A small bracket, curly brackets, a square bracket, or big brackets, means these are the types of the brackets. We have learned these things in the previous classes also. Okay, so what is the order of simplifying? If these brackets will be there in the question, then what will the order to simplify? Means which one will be simplified at first, and which will be simplified after that, means the order. If this type of, suppose that these will be there, then the order will be, at first we will solve the bar, and then the small bracket parenthesis, and then curly bracket, and then at last the square bracket or big bracket, a square bracket or big bracket. So this is the order 1 2 3 4. At first this will be solved, then this, and then the fourth one. So suppose that this is the example. Okay, in this all the three brackets are there: bigger bracket, curly bracket, and a small bracket. So what will we do? We will solve at first the smaller one. Here we can see that if this is not there, then what will the order? At first we will solve this a smaller bracket, then curly bracket, then big bracket. So here at first we will solve the smaller bracket. So it has been solved. You can see that 28, okay, minus, then big bracket starts, then 19 minus curly bracket, then 14 minus what will be? It has been solved. 10 minus 2, then 8. Now a small bracket has been solved. Now curly bracket will be solved. So here you can see everything has been written same here, and minus here 14 minus 8, it means 6 has been written here. And then at last big bracket is solved. It means 19 minus 6, then 13, and then at last we have got the answer. So we have understood the order of the brackets, order of the what, order for simplifying the brackets, what, order of simplifying the brackets. If that all the brackets will be there, then in which manner we will simplify, what will the order, that we have understood. That at first this bar, then a small bracket, then curly bracket, then a square or big bracket. Now to find the divisors, the number of ways in which two coins can be arranged is like this. If two coins are there, then we can arrange like this or like this. Okay, it means 1 into 2 means 1 in, okay, 2 in 1 row, or 1 into 2 row, like this. So we can arrange like this, 1 into 2 or 2 into 1. If 4 are given, then we can arrange in these three ways, like this, 1 into 4, 1 1 1 1, like this. Okay, or 2 into 4, that 2 2 we will put, okay, 2 and then 2, so 2 into 2. Otherwise 4 into 1, at a time 4 we will put, and in one line, in one column it will be kept. So we have a miss, like this we can arrange the given number of coins in the rectangular form. No, these are forming the rectangle. So few more examples are there. Suppose that 6 are given. Okay, then how can we arrange? So 1 1 in each column, 1 in one column, then second column, then third column, then fourth column, then fifth column, then sixth column. It means 1 into 6. Okay, like this we can arrange. Otherwise 3 into 2, it means in one column 3, and then in one column 3. So like this 3 into 2 we can arrange. Otherwise 6 into 1, it means in one column only all the 6 will be arranged. Otherwise 2, okay, 2 2 2, it means in each column 2 2 will be arranged. So like this we can arrange to form the rectangle. It means these are the 4 ways to arrange the given number of the coins, 6 coins. Okay, so why have you done this? Actually here we can see that 1 into 6 is equal to 6. It means we can say that 1 and 6 divide 6 exactly. If 1 into 6 is equal to 6, it means 1 can divide 6 and 6 can divide 6. Okay, in the factor also we have a study that product can be divided, okay, by these numbers of what, this is the product. So suppose that 2 into 3 is equal to 6 there, it means 6 can be divided by 2 and 3 both. Okay, so combining we say that 6 is completely divisible by 1 2 3 and 6. Here we have seen that if 1 into 6 is equal to 6, then 6 can be divided by 6 and 1. If 6 is equal to what, 3 into 6, 2 into 3, 2 into 3 is equal to 6, it means 6 can be divided by this 2 also. It means overall we have found that 6 can be divided by 1 6 2 and 3, all these 4 numbers. So actually we have got the divisors. Okay, 1 into 12 is equal to 12. Another example has been taken, that now consider 12 coins. Then how can it be arranged? 1 into 12, then 12, 2 into 6, then 12, 3 into 4, it means 12, 4 into 3, 12, 6 into 2, 12, 12 into 1, 12. Like this we can arrange. It means what? That actually these are the divisors. These are the divisors of 12. These are the divisors of 12. So like this, in this manner we can find the divisors. Here we can see that 1 2 3 4 6 and 12 are the divisors of 12. In the same way we can find the divisors of any number. Suppose that we have to find the divisors of 18. So 18 can be written like this: 1 into 18, 2 into 9, 3 into 6, 6 into 3, 9 into 2, or 18 into 1. So here these numbers 1 18, 2 9, 3 6, Okay, 6392 means these are the what exact divisors of 18. So in the form of multiplication we will write, and we can get the divisors of any number. So here we have got that the divisors of 18 are 1 2 3 6 9 and 18. So this is very easy way we can find out the divisors of any number. Again consider the number 6. Suppose the 6 is taken, then on dividing 6 by 1, what we get, that quotient we have got 6 and remainder 0. Like this, if we will divide 6 by 2, then what will you do, that again dividing 6 by 2 we get the quotient 3 and remainder 0. Like this, and 6 has been divided by 3, then what have we got, quotient 2 and remainder 0. So like this we'll divide 6 by 4, okay, by 4, then quotient 1 and remainder is 2. And again if 6 is divided by 5, then quotient is 1 and remainder is 1. If it is divided by 6, then quotient 1 and remainder 0. So here we have seen that, here we see that 1 2 3 and 6 are exact divisors of 6 and are called the factors of 6. It means here we have seen that in which case we have got the remainder 0. If we have divided by 1, we have divided by 2, we have divided by 3, then we have got the remainder 0, means these are the exact divisors. But here if we have divided by 4, by 5, then we have got the remainder is left. It means 4 and 5 are not the exact divisors. And again by 6, if we have divided, again it has been divided completely exactly, it means 6 is also the exact divisor. So we have got that 1 2 3 and 6, 1 2 3 and 6, these are the exact divisors of 6, and these are called the factors of 6. So what have you understood, that exact divisors are known as factors. Exact divisors are known as factors. So we can say that factor of a number is an exact divisor of that number. Factor of any number is the exact divisor of that number. So here if we write 5 into 1 is equal to 5, 5 into 2 is equal to 10, 5 into 3 is equal to 15, 5 into 4 is equal to 20, then here we can see that 5 is the factor of 5, 5 is the factor of 10, 5 is the factor of 15, 5 is the factor of 20, like this. Or we can say that 5 can be divided by 5, 10 can be divided by 5, 15 can be divided by 5, 20 can be divided by 5. So these are the multiples, the numbers which can be divided by the given number, that is known as multiple. Okay, so here we have seen that 5, 10, 15 and 20, these can be divided by 5. It means these are the multiples of 5. So 5, 10, 15 and 20, these are the multiples of 5. I hope that you understood factors and multiples. So don't get confused. If we will talk about the factors of 5, then factors are 1 and 5. But if we will talk about the multiples of 5, what multiples, then multiples of 5 are 5, 10, 15, 20, 25, like this. Means factor which can divide, okay, and multiples which can be divided by the given number. So don't get confused between the what factor and multiple. Factors divide the given number, and multiples, what are the multiples, multiples can be divided by the given number. Okay, which numbers can be divided by 5, those are the multiples of 5. Suppose that if I'll ask that what are the factors of 10, then which numbers are the multiples of 10, then 10, 20, 30, because these numbers can be divided by 10. So which numbers can be divided, those are the multiples. Already we have learned in the previous chapter. Now multiples of any number obtained by the multiplying by natural number. If we will multiply any number by the natural number, any natural number, then we get the multiple of that number. Suppose that 6, okay, 6 into 4 is equal to 24, then factors of 6 and 4 are exact divisors of 24. Here 6 into 4 is equal to 24. The number 24 is the multiple of each of the factors of 6 and 4. So you must have understood here that if the product of two number is something, then okay, if this 24, 6 into 4, we have got 24, it means 6 is the factor and 4 is the factor of 24. And with this, the whatever the factors are of 6 and 4, those will be the factors of 24 also. Okay, a factor of a number is exact divisor of that number. We have understood a factor is a multiple of its factor. A number is the multiple of its factor. Obviously, this is the what 24, and these are the factors. So we can say that 4 and 6 and 4 are the factors of 24. And in the opposite way, another way we can say that 24 is the multiple of 6 and 4. So we understood that the number is the any number is the multiple of its factor. Okay, multiple of its factor. Suppose that I'm talking about 5. So 5 is the its factors are 1 and 5. So factors of 5 are 1 and 5. If we'll talk about the multiple of 1, then 5 is the multiple 1. 5 is the multiple of 5. So we have got that a number is the multiple of its factors. If you write 24 is equal to this 3 into 8, then we say that 3 into 8 are the factors. 3 and 8 are the factors. Obviously in the beginning we have learned that if anything can be expressed in the multiplication form, then whatever numbers are used, they are the factors of the product. No, so 3 and 8 are the factors of 24, and 24 is the multiple of its factor. So we have understood this. So like this we can find the multiple and factor. Already we have learned in the previous chapter. So these are the examples, you will read it. Okay, stop the video and try to understand. Already we have learned. So this actually, these are the, actually we can say that revision chapter of factor and multiple. So 1 is the factor of every number. We know that 1 can divide each and every number. So 1 is the factor of every number, and every number is the factor of itself. Any number can be divided by itself. 5 can be divided by 5, 10 can be divided by 10, 2 can be divided by 2. So every number is a factor of itself. Okay, so here you can see the example. Now here let's take the example. Suppose that yeah, these things already we have learned. Let me show you. Yeah, for a given number, each of its factor is less than or equal to number. The factor in simple way, here you can see, observe the factors of 4 are 1, 2, 4, factors of 15 1, 3, 5, 15, factors of 36 1, 2, 3, 4, 9, 6, 6, 9, 12, 18 and 36. These are, so here we have observed that the factors are either smaller or equal to the number. Okay, factors cannot be greater than the number, never. Factors are smaller than or equal to the number, that only it is there, that each of the factors is less than or equal to the number. Okay, and we can say that factors of a given number are finite, it means countable. So any number has a certain number of factors, 2 factors, 3 factors, 5 factors, 7 factors, like this. So every number has a finite number of factors, limited number of factors, that is countable. Okay, so now each factor of 32 is less than, obviously each factor of 32 will be less than. Here you can see that factors of 32 are these, and every factor are less than or equal to, less than or equal to 32, no, and are finite numbers. Okay, so now we'll talk about the multiples. Multiples of 5 are 5, 10, 15, 20, 25. If you keep on writing, then it will not in, it will go to infinite, like 5, 10, 15, 20, 25, 30, 35. Means there are infinite number of multiples of 5, means infinite numbers which can be divided by 5. So we have observed that any number has infinite number of multiples. Okay, countless number of multiples, and multiples are always greater than or equal to. You can see that all the numbers are greater than or equal to, except 5, all the numbers are greater than. So multiples can never be smaller than the given number. So every multiple of a number is greater than or equal to the number. Every number is the multiple of itself. You can see that 5 is the multiple of 5, 6 will be the multiple of 6, 7 will be the multiple of 7. So every number is the multiple of itself. The number of multiples of a given number are infinite. The number of multiples, if I ask that how many multiples are there of 5, then that will be what? Countless. The number of multiples is countless, it is infinite. Okay, example 1. Here we can see example 1, that write all the factors of 56. What will we do? We will write in the form of multiplication, that 1 into 5, 1 into 56, 2 into 28, and 3 into something cannot be written, because if you will divide by 3, then it will not get remainder 0. So 4 into 14, like this, it can be written. 7 into 8, it can be written. So we have observed that here, if we write like this, then 1 and 56, these are the factors. 2 and 28, these are the factors of 56. 14 and 4, these are the factors of 56. 7 and 8, these are the factors of 56. So we have got that 1, 56, 2, 28, 4, 14, 7, 8, these are the factors of 56. So we have got the factors of 56. Whenever we will have to write the factors of any number, then we will just write it like this in the form of multiplication, and whatever numbers are in the multiplication, those will be the factors of the number. Okay, so like this we can find. So now if we'll have to write the multiples of 7, then it's very simple. Whenever we will have to find the multiple, then we just multiply the given number by the natural number. Suppose that we have to write the multiples of 7, one by one we will multiply the 7 by 1 2 3 1 by 1. So 7 into 1 7, 7 into 2 14, 7 into 3 21, 7 into 4 28, 7 into 5 35. So like this we can find out many multiples. So whenever we'll have to find the multiples, we'll multiply the given number by the natural number, then we'll get the multiple of that number. So like this we can find the multiples of any number. Here multiples of 7 has been written, and after that dot 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 has been given. Why? Because we know that there are infinite number of multiples. So few multiples we will find, and after that we will put the dot. Dot indicates that it will go to infinite. Okay, because it is saying only that write the multiples of 7, it is not saying that how many multiples. So simply it is saying write the multiples. So few multiples we will write, and after that we will put the dot dot. It means it indicates that it will go to infinite. But in the question number 3, example 3, you can see here, actually example 2 should be there. Example 3 is saying that write first 6 multiples, first 6. So here it is saying the 6 multiples, so we'll write only 6, will not give the dot dot. So first multiple will be 1 into 8 or 8 into 1. Then second, what, first multiple will be 8 into 1, and second will be 8 into 2, sorry 16. Third will be 8 into 3 24. Like this we can find the multiples of the given number, means 8. So we will keep on multiplying the given number by 1 by 2 by 3 by 4, like this one by one, and we'll get the multiples of the given number. So like this we'll multiply, and we'll get the 6 multiples, and those 6 will be the answer, because we have to write only 6 multiples here. Only 6 multiples we have to write. So we'll write the 6 multiples, and after that we'll stop here. But if it will not say the number of multiples, that how many you have to write, then few multiples you will add, and you will put the dot 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 simply. Okay, so in this session this much only. All of you, bye, have a nice day.